This is Professor Pelton. This is Trigonometry, Chapter 3, Section 1, Applications of Trigonometric Functions. This is Part 1 of 2. Okay, so here we're going to do generic cases of right triangles. What's important is when you label the angles, they are uppercase letters, and the sides are lowercase letters. So lowercase for the sides, and uppercase for the angles. Also, the angle and the side are also opposite their corresponding upper and lowercase letter. And what's also important is you use C for the hypotenuse, and that's the angle opposite the hypotenuse in the generic cases. So in the non-generic cases, it doesn't matter. Okay, let's do some examples. So, solving a triangle, a right triangle, means to find all the corresponding sides and angles. So in this case, we'll be solving right triangles in this section and non-right triangles in further sections. Okay, so first off, we can find the angle. So the two angles, other than the right angle, add up to 90 degrees because the total is 180. So angle B must be 90 minus 34.5 degrees. Thus, angle B would be 55.5 degrees. Okay. At that point, you can use either angle to find the remaining side lengths using the ratios of SOHCAHTOA. Okay. So if we're going to use the 34.5 in A, that's going to be the tangent. Since I have one side, which is B, I have to use, which is going to give me opposite and adjacent. So tangent of 34.5 degrees equals A over 10.5. Okay, so in order to solve that, I have to multiply both sides by 10.5. Let's multiply, let's change the color here. This side by 10.5, multiply that side by 10.5. So as a result, cancels. So 10.5 times the tangent of 34.5 degrees equals A. Make sure when you put in the calculator you have a degree mode since you're plugging in degrees, and you will get 7.22 approximately. Okay, so we'll box our answer there, and we'll box our answer there. So this gives us about 7.22. Alright, so the last piece is C, and if I use the 34.5 again, that's going to give us the adjacent and a hypotenuse. So it'll be a cosine function. So we have the cosine of 34.5 degrees equals our 10.5 over C. So multiply both sides by C this time. Which will cancel the C, leaving me with C times the cosine of 34.5 degrees equals 10.5. Now we'll divide by the cosine angle. Get C by itself. Cancel. And again, make sure your calculator is in degree mode since you are plugging in degrees. And you get about 12.74. Okay, so that is about 12.74, and what you should notice is the largest angle is across from the largest side, and the smallest angle is across from the smallest side, and the medium side is across from the medium size angle. So we know how we have the correct ratio here. Alright, pause the video, try the student problem. Okay, in the student problem, it doesn't matter how you draw the triangle, as long as C is the hypotenuse. So if we draw a triangle, alright, that has to be C, and the other ones can be A or B or B or A, it's your choice. So I'll do A and B going that way. So that means the remaining sides are lowercase b here, lowercase c here, and lowercase a here. And the given information is the A angle is 62.7 degrees, and the side A is 8.4. So using our triangle angle theorem, they have to come up to 180. My angle B must be 90 degrees minus the 62.7 degrees. Thus, angle B must be 27.3 degrees. Okay, so that means you can use either angle, the 62.7 or the 27.3, to find the remaining sides. So if we use the 62.7 and we want to find the remaining sides, if we want to find B first, that's going to take us a couple different ratios, but the only ratio we're able to do with a known side is with this side. So that's going to be opposite and adjacent to 62.7. That's a tangent function. So tangent of 62.7 degrees equals the 8.4 over B. Okay, so we'll solve that. Okay, now we want to get the B by itself, so divide by the tangent of the angle. Okay, tangent cancels, so B is approximately. Again, make sure you use the angle measure in your calculator since you're putting in degrees. So if I plug that in, I will get approximately 4.34. Okay, so I plug that in. That's about 4.34. What's important here is when I solve for the C, I can't use the B because B is an approximation. That would throw my answer off. So I have to use the A again to get an answer that's closer to the real answer. Okay, and if I do that, that's going to be opposite and hypotenuse, which is the sine. So that means the sine of 62.7 degrees equals the opposite over the hypotenuse. And we can solve thusly. Let's multiply by C on both sides. So C times the sine of the angle equals 8.4. And divide by the sine of the angle. Okay, again, make sure it's in degree mode since you're typing in degrees. And C will get about 9.45. What you'll notice again, the right angle is across from the largest side because it's the largest angle, and the 27.3 degrees, which is the smallest angle, is across from the smallest side, which is 4.34. Okay, so those are solving generic right triangles. Let's do some word problems now. Okay, a person stands 125 feet from a radio tower and determine the angle of elevation of the ground. And determines the angle of elevation from the ground is 57.2 degrees. So angle of elevation is from my horizontal, so that's our horizontal. And going up is elevation. That's 57.2. So we want to know the height of the tower, which is here. Okay, so that's going to be our opposite and adjacent. So that's tangent. So tangent of 57.2 degrees equals the A over 125. So we'll times both sides by 125. Cancel, cancel. So 125 times the tangent of 57.2 degrees equals A. Again, make sure it's in degree mode. So that gives you about 193.96, which is the incorrect answer because it's needed to be 193 something. In this case, it'll be feet. Okay, pause the video. We'll try the student problem. Alright, a person flies a kite that is 30 feet in the air, and he lets out 65 feet of rope or string. Determine the angle of elevation, so that's right here, and the distance the person is. So we're going to make that as B, I guess, in this case. You can call it any letter you want, though, really. Alright, so this is a right triangle. We do not need to use trigonometry here. We can use our basic geometry for the Pythagorean theorem. So 65 squared equals 30 squared plus b squared. So 65 squared is 4225. 30 squared is 900. So we'll move the 900 over. So that gives me 3,325 equals b squared. So plus or minus the square root of 3325 is b. But we only need the positive answer. That actually breaks down to 5 root 133, which is approximately 57.66. Okay? But we want to use the exact answer here. So 5 root 133, and it's in feet. The reason being is when we find our angle, we don't want to use approximations because the approximations will throw our angle off by several degrees, so use the exact answer. So at this point, you can choose any of the sides that you want to find the angle as long as you use the exact numbers. Using the ones that they gave us, of course, that would be sine because it's opposite and hypotenuse. So that would be the sine of angle A equals 30 over 65. So to be able to solve that, I have to do the inverse sine to both sides. So the inverse sine of sine on the left and inverse sine of the ratio on the right gives me an angle. Let's cancel, cancel. So angle A is approximately 27.49 degrees. So that's about 27.49 degrees. Okay, next page. Alright, your friend stands 100 feet from the launch pad of a hot air balloon. Your friend takes two angles of elevation readings from the ground. The first angle of elevation is 31.7 degrees. A minute later, the angle of elevation is 76.2 degrees. Determine the rate at which the balloon is ascending. Assume the rate is constant. So we have a small triangle and a big triangle as a result, and they both have heights from the ground, which is A and B. So figure out those heights first. So they're both going to be using the 100 feet back, and that's both are going to be opposite over adjacent, which is tangent. So the tangent of 31.7 degrees is the A over 100, and the tangent of 76.2 degrees is the B over 100. So timesing both sides by 100 in each case gives me A is equal to 100 times tangent of 31.7 degrees, and B equals 100 times tangent of 76.2 degrees. Okay. Again, that both we want to get, we don't want the answers for A or B though, because we really want this distance here. That's the distance we want. So we'll call that the distance D. How's that sound? So D is actually going to be the whole thing, which is B, minus the partial distance at the bottom, take that off, which is A. Okay, so if you plug that into your calculator, using the B minus A on the top here, that's going to be 100 times tan of 76.2 degrees minus the 100 times tan of 31.7 degrees. Okay, that'll give us a distance of approximately 345.37 feet. But the question is asking for a rate, and we're assuming that it's constant. So the rate will be a ratio, which is the 345.37 feet. Oops. Since the two readings were done over the course of, was it 1 minute, I believe? That is the rate at which the balloon is moving. It's pretty fast. Okay, pause the video, try the student problem. Okay, person stands 800 feet from Mount Rushmore. Person takes 2 readings from the face of Abraham Lincoln. The angle of elevation to the bottom of the face is 32 degrees, and the angle of elevation to the top of the face is 35 degrees. Let's draw a picture. So there's somewhat of a face there. And the distance to the ground, distance over, is 800 feet. And our 2 angles, so our first angle to the bottom of the face is 32 degrees. And to the top of the face, so that's 32. So that one is 35 degrees. So we'll call this the base, and we'll call this the whole thing. And we'll call this piece right here just the face height. Okay? So if we want to find B, that's going to be a tangent. So tangent of 32 degrees is the B over 800 for the bottom, using the small angle. And to the top of the face is 35 degrees. So the tangent of 35 degrees equals the whole thing over 800. So you multiply each side of the equation by 800. You're going to get B equals 800 times tan of 32 degrees. And W equals 800 times tan of 35 degrees. Okay, but we don't want B or W, we want F. And F is equal to the whole thing minus B. So if we plugged in W minus B into the calculator, again, we don't want to round to the incremental step, that's why I want to keep them in the equation format. So we would get the 800 times tan of 35 degrees minus the 800 times tan of 32 degrees. So my face will be approximately 60.27 feet for old Abe. And that is the end of part 1.